In Activity 8, Propeller Planes, students learn how thrust is produced in propeller airplanes. They first relate the shape of a propeller blade to an airfoil and then assemble a model propeller plane. Students observe how spinning propellers produce thrust and conclude that an increase in power results in an increase in thrust. You will need the following materials from the kit: Activity Sheet 8, Parts A and B, Wingless Wonder Packet, fishing line, a roll of masking tape, and tongue depressors. You will also need to provide a pair of scissors, pictures of airplanes from Activity 7, and a metric ruler. To prepare for the activity, make a copy of Activity Sheet 8, Parts A and B for each student. Cut one 6-meter length of fishing line for each team of 4. Wrap each length of fishing line around a tongue depressor and tape the ends in place. Clear some space in the classroom for students to set up their runways. Each team of 4 will need a Wingless Wonder Packet, a metric ruler, a tongue depressor wound with 6 meters of fishing line, and 2 pieces of masking tape. The packet contains an airplane stick, a propeller with nose assembly, a plastic hook, a straw, 2 pipe cleaners, and 2 rubber bands. To begin the activity, have students recall their work with paper airplanes in Activity 5. Remind them that their arms provided the power to launch the planes. Explain most airplanes have fuel-burning engines that provide thrust, the power that propels the aircraft through the air. Distribute the pictures of airplanes for students to examine again. Tell students that there are 2 types of power sources on airplanes. Large airplanes, called jets, have jet engines that suck in air and blow it out the back of the engine. Other smaller planes have engine-driven propellers that spin at high speeds. Have students find both types of planes in the pictures. Next, hand out a copy of Activity Sheet 8, Parts A and B to each student. Bring students' attention to the diagram of the propeller at the top of Part A. Explain that blades are the long, thin, paddle-like structures. Small prop planes may have 1 or 2 engine-driven propellers with 2 to 3 blades per propeller. Larger prop planes may have as many as 4 propellers with 3 to 6 blades per propeller. Point out the hub, the spot in the center of the propeller, where the blades attach to the engine. Next, guide students to look at the cross-sectional diagram of a propeller blade at the bottom of Part A of their activity sheet. Students should recognize it as an airfoil. As the propeller blades spin, air flows faster over the curved front surface of the blades than over the flat back surface, resulting in a pressure difference between the front and back of each blade. Because of the way that the propeller is tilting, the pressure difference pushes the plane forward instead of upward. Forward movement is called thrust, while upward movement is called lift. Next, divide the class into teams of 4 and give a Wingless Wonder packet to each team. Instruct students to build the Wingless Wonder. First, place the propeller with nose assembly on one end of the airplane stick and the plastic hook on the other end of the stick. Then, slip the rubber band through the metal loop in the nose assembly and attach the other end to the plastic hook at the opposite end of the stick. Then, attach 2 pipe cleaners to either end of the airplane stick. Secure each pipe cleaner to the stick by twisting one end around the stick twice. Make sure the wrapped ends of the pipe cleaners do not touch the rubber band. Finally, twist the free ends of each pipe cleaner around the straw so that the straw and airplane stick are parallel and about 7 centimeters apart. Tape the pipe cleaners to the straw using 2 pieces of masking tape. Next, distribute a tongue depressor with fishing line to each team. Help them set up a runway for their craft by placing 2 chairs about 4 meters apart. Tie one end of their fishing line to the back of one chair, thread the other end through the straw, then tie the free end to the back of the second chair, pulling the line tight so it does not sag. Have students slide their Wingless Wonder so that its tail end almost touches the chair at one end of their runway. Tell students to hold the stick while they wind the propeller in a clockwise direction 20 times. Be sure they notice that the rubber band is twisting. Now ask, what do you think will happen if you let go of the propeller? Students should realize that the propeller will spin as the rubber band untwists. Have students hold the airplane stick but let go of the propeller. Ask students, what is the engine in your Wingless Wonder? They should conclude that the twisted rubber band is the engine. Next, have students wind their propellers 30 times in a clockwise direction and then release them. Now ask, what happened to your Wingless Wonder? Students should understand that the propeller created thrust, which moved the Wingless Wonder forward along the fishing line. Have students return their wingless wonders to the beginning of the runway. Distribute a ruler to each team. Once again, have students wind the propeller 30 times and release the craft. This time, tell them to measure the distance it traveled and record their measurements. Repeat this procedure twice more, first winding the propeller 40 times and then 50. After students have finished, ask, "What conclusions can you draw from your data?" Students should conclude that the more times they wound their propeller, the faster the propeller unwound and the greater the thrust. The greater the thrust, the farther and faster the wingless wonder traveled. Inform students that in the next activity, jet planes, they will learn about engines developed in the past 30 years that have made air travel faster and safer than ever before. To conclude the activity, cut down the fishing line runways and discard them. Tell students to disassemble the wingless wonders and put all of the parts back in the packet. Return the packets, the rolls of fishing line and tape, and the tongue depressors to the kit. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.